Today we are going to learn about using AI to combat climate change. By the end of this video, you will understand how to leverage AI tools and frameworks for environmental analytics. As climate change continues to pose significant risks to our planet, the role of artificial intelligence, AI, in understanding and mitigating these effects becomes critical. AI technology provides powerful tools for environmental monitoring, offering predictive modeling capabilities that help anticipate weather patterns and optimize renewable energy sources. By leveraging AI, we can analyze carbon footprint data more accurately and implement strategies to reduce emissions. In this video, we'll explore how AI models can be applied to combat climate change, empowering you with the skills to make a meaningful impact in environmental analytics. AI plays a vital role in environmental monitoring by providing real-time insights into the health of our ecosystems. Through advanced sensors and data analytics, AI can detect changes in the environment that may go unnoticed by human observation alone. These technologies can track everything from deforestation and pollution levels to wildlife population dynamics. For instance, AI-powered satellite imagery can identify illegal logging activities, allowing for prompt intervention. Additionally, AI systems equipped with IoT devices can collect and analyze vast amounts of environmental data, offering insights that inform conservation efforts and policymaking. This capability is crucial for maintaining ecological balance and addressing the impacts of climate change on biodiversity. One of the most promising applications of AI in combating climate change is predictive modeling for weather patterns. By harnessing machine learning algorithms, AI can analyze historical weather data and identify patterns that help forecast future climatic events. This is particularly beneficial for predicting extreme weather events such as hurricanes, floods, and droughts. Accurate predictions enable communities and governments to prepare and respond effectively, thereby enhancing climate resilience. AI models can process vast datasets much faster than traditional methods, providing timely insights that are crucial for disaster preparedness and mitigation efforts. This technological advancement not only saves lives but also minimizes economic losses associated with natural disasters. AI technology is revolutionizing the way we manage renewable energy sources, making them more efficient and reliable. Through AI-driven analytics, we can optimize the performance of solar panels, wind turbines, and other renewable energy infrastructure. For example, AI can predict energy production based on weather forecasts, allowing for better energy grid management. Smart grid technology, powered by AI, enables the efficient distribution of energy by balancing supply and demand in real time. Furthermore, AI facilitates advanced energy storage solutions, ensuring that excess energy generated can be stored and used when needed. By improving the efficiency and reliability of renewable energy sources, AI helps reduce our reliance on fossil fuels, ultimately contributing to a more sustainable future.
AI provides powerful tools for analyzing carbon footprint data, enabling organizations and governments to identify key sources of emissions and implement data-driven strategies for reduction. By leveraging machine learning algorithms, AI can assess vast amounts of data from various sectors, such as transportation, industry, and agriculture, to pinpoint areas where emissions are most significant. This analysis helps prioritize efforts to reduce carbon output effectively. AI tools can also monitor progress in real time, offering insights into the effectiveness of emission reduction initiatives. By providing a clearer understanding of carbon footprints, AI empowers stakeholders to enhance sustainability efforts, align with environmental policies, and achieve climate goals. Several case studies highlight the successful application of AI in reducing emissions across various sectors. In urban planning, AI-driven models have been used to design energy-efficient buildings and optimize transportation systems, significantly lowering greenhouse gas emissions. For instance, cities like Singapore and Amsterdam have implemented AI technologies to manage traffic flows, reducing congestion and emissions. In the energy sector, companies are using AI to enhance the efficiency of power plants, leading to substantial reductions in carbon output. These real-world applications demonstrate AI's potential to make a significant impact on global emissions, showcasing its role as a powerful tool in the fight against climate change.
A variety of tools and platforms are available for implementing AI solutions in environmental applications. These include open-source software like TensorFlow and PyTorch, which offer powerful libraries for developing machine learning models. Commercial platforms such as IBM's Watson and Google's AI tools provide robust frameworks for integrating AI into existing environmental systems. These tools enable the analysis of large datasets, facilitating the development of scalable and effective climate solutions. Additionally, AI platforms offer APIs and cloud-based services that allow for seamless integration with existing systems, enhancing their capabilities. By leveraging these tools, organizations can deploy AI-driven solutions that address specific environmental challenges and contribute to sustainability goals.
While AI offers significant potential in combating climate change, it is essential to address the ethical considerations associated with its deployment. One major concern is the potential for bias in AI models, which can lead to inaccurate predictions and unintended consequences. Ensuring that AI systems are trained on diverse and representative datasets is crucial to minimizing bias. Additionally, data privacy is a significant concern, particularly when collecting and analyzing large amounts of environmental data. Organizations must implement robust data protection measures to safeguard sensitive information. Furthermore, the energy consumption of AI systems themselves must be considered, as their carbon footprint can offset the environmental benefits they provide. Responsible deployment of AI in environmental applications requires a commitment to sustainability and ethical practices. Looking ahead, the role of AI in climate action is poised to expand as emerging technologies continue to evolve. Future trends include the development of collaborative AI solutions that involve multiple stakeholders, such as governments, NGOs, and private sectors, working together to address climate challenges. AI is also expected to play a more significant role in shaping climate policy by providing data-driven insights and recommendations to policymakers. As AI technologies advance, their applications will become increasingly sophisticated, offering new opportunities for enhancing sustainability efforts. The long-term impact of AI-driven climate action will depend on continued innovation and collaboration, ensuring that these technologies are leveraged effectively to combat climate change and promote a more sustainable future. In conclusion, AI holds immense potential as a solution for combating climate change and promoting sustainability. By providing powerful tools for environmental monitoring, predictive modeling, and emission reduction, AI empowers individuals and organizations to take meaningful action in addressing climate challenges. As technology continues to advance, the role of AI in climate action will only grow, offering new opportunities for innovation and collaboration. It is crucial for stakeholders to embrace these technologies responsibly, ensuring their ethical deployment and maximizing their positive impact on the environment. We encourage you to explore AI-driven solutions in your own initiatives, contributing to a sustainable future for our planet.